Here we can see I'm using a probe, an oscilloscope probe that hasn't been compensated. I'm looking at a square wave here. It's 1,000 hertz, and it is quite, the tops are asymmetrical. They don't look good at all. So what I'm going to do is I'm going to show how to adjust this scope probe to make the square wave symmetrical, flat topped. Right here I'm showing a scope probe which I have on hand, and I wanted to put it on this old Fluke 96 scope meter. And now, while the Fluke scope meter has its own internal mechanism where you can set it up so it will adjust itself to a Fluke probe, you can also put any probe on the Fluke scope meter, 10-to-1, a typical 10-to-1 probe. And here I've got it, there's 1 times and there's 10 times. Now what I'm doing is I'm going to show how you can adjust any probe that has this compensation capacitor right here, and you just basically put a screwdriver in there and you just turn it until, while you're looking at the waveform, and you can make it completely flat topped. Now 1,000 hertz is what most manufacturers recommend that you that's the frequency of square wave you adjust a probe with. So I'll demonstrate how to do that. So here I've got it all set up, and you can see there's a bit of a delay there, but as I turn the capacitor adjustment, I can adjust it so that it's pretty symmetrical. Maybe what I'll do is I will just make this a little more so I can see it, the flat tops better. There. Just by adjusting the frequency there, or by adjusting the, here we are. Now, see if we can get that again there. There's a delay there, about a couple of seconds, so when you make the adjustment you have to wait for it to settle down. That looks pretty good there. I think I will leave it at that. Let's see what it looks at. Let's see what it looks like. There, that looks pretty good. There. Not bad. It still looks pretty good. Now if I took this scope probe to another oscilloscope, I'd need to adjust it again, because each oscilloscope has slightly different characteristics, so that capacitor has to be adjusted each time. On the 1 times, 1-to-1, it doesn't really matter because you don't have it going through a capacitor. But of course, that is for lower frequency. The capacitor is for higher frequencies. And that's why you adjust it for the best compromise. Use a square wave because a square wave has an infinite number of harmonics in it. So you're compensating it for the best possible scenario at all the frequencies that the oscilloscope will cover. This oscilloscope will go up to 50 megahertz and higher. And if I feed any other waveform into this that the scope can handle, it'll look pretty accurate now that I've adjusted it and compensated it. Here's a modern oscilloscope, and you can see that it's got its own 1,000 hertz square wave right on the front panel. And most oscilloscopes are like that today. But sometimes you have to use an external oscillator to do it with the older scopes to compensate them. Here is a properly compensated modern scope. But if I have to adjust this, the adjustment is to be made in the base. In this one, it's right here, right? The adjustment capacitor is right here. So if I had to make any compensation, that's where it is. So here you can see that it's uncompensated. So here is where I compensate. I turn the compensation tool, put it here. I have to use the one that came with the oscilloscope because the other one that I used was metallic. This one, you cannot do it unless you're using a plastic tool. So there it's really uncompensated, and then I turn it down, and there. It's nicely compensated. Looks pretty good. Just turn it down to line up with the grid there, and it looks really good. So that's how you compensate for two different types of oscilloscopes, an old one and a modern one, modern digital scope.